Hello and welcome, my dear grade 11 advanced students, to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming you to another video based on popular demand from my students and subscribers. So here I am with you for revising FRQ Learning Objective 17, which is based on De Moivre's theorem. So first I will quickly explain you the De Moivre's theorem. We are going to use it for the power, and then I will show you the questions that we will be solving. So De Moivre's theorem, first of all, is always applied to polar form. That means even if you are given a complex number like in rectangular form z equal to a plus ib, this is rectangular form, then first you convert it to polar form, that is you use r equal to square root a square plus b square to get your r, and you also find the angle theta, which is tan inverse b by a if a is positive, and it is equal to tan inverse b by a plus pi if a is negative. Okay, so you use whichever formula that is applicable as per the value of a. If a is negative, just add pi. So you do this conversion, you get your r and theta, and then you write your polar form of the complex number as z equal to r cos theta plus iota sine theta. Okay, this is the complex number. Now if you get a question on power, means like the complex number is to the power 6, 5, 4, 7, any positive number, then you use this De Moivre's theorem where you raise r cos theta plus iota sine theta to the power n. So what happens? The power gets on top of r, so r is to the power n, and the angle gets multiplied with n. So if the previous angle was theta, which is cos theta plus iota sine theta polar form, then it gets multiplied with n. So this formula is called De Moivre's theorem to find the power. And now let's look at the question from Learning Objective 17 and see how we can apply this De Moivre's theorem to find the power and give the answer. Okay, let's now move to question number 17, which is learning objective. Find products, question, powers, and roots of complex number in polar form. So definitely De Moivre's theorem is what we are going to be using. Let me first write the theorem for you. And remember, in order to apply De Moivre's theorem, we have to first convert to polar form. So we are going to convert this question into polar form, and then we are going to apply the De Moivre's theorem. So De Moivre's theorem says that if you have a complex number in polar form r cos theta plus iota sine theta given to you, and you want to calculate its nth power z to the power n, then to this polar form of the complex number you raise everything to the power n, and your r becomes to the power n. However, your angle gets multiplied by this n. That's your De Moivre's theorem. So let's apply this. This is my x, this is my y. So first I'm going to find my r and theta so that I can convert to polar form. So this is going to be 2 square plus 2 square root 3 square, which is, with your calculator, it will come out to be square root of 64, which is 8. Okay, so which formula did I use? R square is a square plus b square, or r is square root x square plus y square. Same thing. Now we need the angle. So for angle, we need to do tan inverse y over x. Both are positive, so no need to add pi. So tan inverse 2 square root 3 divided by 2. So use your calculator. Tan inverse of square root 3 will come out to be pi by 3. So we have both the things. We have r, we have theta. Now, due to lack of space, I'll be doing question 37 next slide. Let's continue this question here. So now I can write my polar form, r cos theta plus iota sine theta. This is my polar form. Let's put the value. R is 8, theta is pi by 3. Now which power we need to calculate in question 36? We need to calculate power 6. So I will raise this to the power 6, and by De Moivre's theorem the angle gets multiplied with n. So 6 pi by 3. I multiply with 6 the angle. Let's see what we can simplify. Use your calculator. 8 to the power 6 will come out to be a big number. It's 2621445. for big number. And this is cos 2 pi plus iota sine 2 pi. Sine 2 pi is 0. So imaginary part is gone. I'm just left with cos 2 pi, which is 1. So my final answer is going to be 262144. This is my final value for the answer for question 30. Okay. Okay, let's solve this question on de Moivre's theorem. First, we are going to convert it to polar form. So to write it into polar form, we are going to use the formula r equal to square root of p square plus p square. And for the angle, we are going to use tan inverse b over a. Now, first, let's convert this question into the standard form for the complex number. A complex number can be written as a plus ib. So here if you see, the iota part is before, the number is separate. So this question should be written in this manner first, and then we are ready to solve it. Okay, so what is my a now? Minus 5. What is my b now? 12. Remember, iota is indicating the imaginary part, which is I. So we're not going to take it in the value of a and b. So let's get my r now. So minus 5 whole square plus 12 square. So this will come out to be square root of 25 plus 144. So this is coming out to be 30. This is r. Now for this question, if you see, your a is negative, it is minus 5. So whenever your a is negative, you have to add pi to get to the angle. So when I do that, I get tan inverse b is 12, a is minus 5, and then we add to this pi. If you use your calculator correctly, this will come out to be decimal, approximately equal to 1.97. So now we are ready to write the polar form. So the polar form of the complex number is r cos theta plus iota sine theta. So let's put the value. R is 13, then cos 1.97 plus iota sine 1.97. Now that we have converted to polar, let's use de Moivre's theorem. The power here is 3, so that means I have to find z to the power 3, which is r to the power 3 cos 3 theta plus iota sine 3 theta. So I'm going to put it to this power. This power 3 means 13 to the power 3, which if I use the calculator will come out to be 2.97. Then for the angle we multiply by 3, so 3 multiplied with 1.97 plus iota sine 3 multiplied with 1.97. So let's solve this. Use your calculator. So this thing comes out to be, after completing your values, putting in the calculator, the final answer I will write here now. Just you can put the calculation in the calculator and it will come out to be 2035 minus 828. Okay, so just put this thing in calculator, you will get your answers. It will be decimal, so that's why this 13 to the power 3 will result into this answer. So this is the final answer for this question. Let's do some more questions on the same learning object. Now if you see question 38, this is more simple because here the question is already in polar form, r cos theta plus iota sine theta, and the power is also given as 4. So because in this question we need not convert to polar form, so directly we can apply de Moivre's theorem. So what does it say? If you want to find the fourth power, then r will be raised to the power and the angle will be multiplied with the power. So 4 gets multiplied to the angle, and I can simplify this using my calculator. 4 to the power 4 will be 256, and for the angle 4 and 2 will be divided, so this will become cos 2 pi plus iota sine 2 pi. Now you can put your calculator in radians, calculate this value. Cos 2 pi would come out to be 1 and sine 2 pi is 0. So because this is 0, this term is gone. Only we have the real part, so 256 multiplied by 1, so the answer is 256. Let's do 39 also. For 39, one additional step is to convert to polar form. So again, I will use the same formula, r equal to square root a square plus b square. A is square root 3 and b is 1. Don't take iota, this is very important. So a is this, b is minus 1, and the power n is 3. Okay, these are the three variables. Let's plug in. Take the square, use your calculator. So this will come out to be 2. So that's your value of r. Let's go to the angle theta tan inverse b over a, put the values. So tan inverse, this time it is negative, so negative 1 over square root 3. So when you use your calculator, this comes out to be in radians, pi by 6. So we have the value for the polar form. Let's now do the De Moivre's theorem. So for De Moivre's theorem, z is equal to, what's the power? Let's write the power first, 3. N is 3. You can see it from here. Now I'm putting the value of r, then cos pi by 6 plus iota sin pi by 6. This is my complex number. So the De Moivre's theorem says the power comes to r. So 2 to the power 3, that will come as 8. And then for the angle, it is multiplied. So 3 gets multiplied with pi by 6. So the new angle is 3 pi by 6. Again, you can do some cancellations here. So it will become pi by 2 in the next step. So the final answer would be 8 multiplied by cos pi by 2 plus iota sin pi by 2. Now use your calculator, put the values. Cos pi by 2 will be 0, sin pi by 2 will be 1. So just calculate this value. So this will come out to be cos pi by 2 is 0, sin pi by 2 is 1, so 8i. This will be the final answer. Let's see the answer key now for this learning objective number 17. So here now, as promised, I'm providing you the answer key for learning objective 17. For all the questions that we solve where we need to find the power and express in rectangular form using the De Moivre's theorem, these are the answer key for question 36, 37, 38, 39, 40, 41, 42, 43, 44 and 45. And yes, just a quick thing which I want to point out. For the previous question 39 that we did in the last slide, square root 3 minus iota whole to the power 3, there is a negative sign. That's why the answer is going to be negative 8i and not plus 8i, okay, because there's a negative sign.